In this video, we're going to talk about how to find the directional derivative as well as the gradient vector. So let's start with this problem. Find the directional derivative of f of x comma y in the direction given by the angle theta pi over 3. So the formula that we need is this. The directional derivative of f is the partial derivative of of f with respect to x times a plus the partial derivative of f with respect to y times b. And a and b come from the unit vector. So first, let's begin by finding the unit vector because we have the angle. So the unit vector is going to be cosine pi over 3 comma sine pi over 3. Now, cosine pi over 3, we know that's 1/2. Sine pi over 3 is the square root of 3 over 2. So we have A and we have B. Now, let's find the directional derivative. But first, we need to determine f of x and f of y. So the function, let's start with that first. That's 4x cubed minus 3xy squared. Now let's find the partial derivative of f with respect to x. So we're going to treat y as a constant. The derivative of x cubed is 3x squared, and the derivative of x is 1. So this is going to be 12x squared minus 3y squared. So we're going to use that soon. Now let's find the partial derivative of f with respect to y. So we're going to treat x as a constant. The derivative of 4x cubed will be 0. The derivative of y squared will be 2y. So this is going to be negative 6xy. Now let's plug in everything into this formula. So the directional derivative of f is going to be f sub x, which is 12x squared minus 3y squared. And that's going to be times a. A is 1/2. And then plus f sub y, which is negative 6xy, as we could see here. And then times b, which is the square root of 3 over 2. Now we could simplify our answer. So if we distribute the 1/2, this is going to be 6x squared minus 3 over 2 y squared. And then 6 over 2 is 3, so this is going to be 3 root 3 xy. So this is the answer to part A. That is our directional derivative in terms of x and y. Now before we go on to part B, let's get rid of a few things. So part B, evaluate the directional derivative at the point 1, 2. So let's replace x with 1, y with 2. So it's going to be 6 times 1 squared minus 3 over 2 times 2 squared minus 3 root 3 xy, 1 times 2. So this is going to be 6. 2 squared is 4 divided by 2, that's 2 times 3, which is 6. And then 3 and 2 is also 6 again. So that's 6 root 3. These cancel. So the final answer is negative 6 root 3. So the evaluation part is not bad. You just got to plug in your x and y values. So now you know how to find the directional derivative given two variables such as x and y. Let's move on to our next example problem. Number 2. Find the directional derivative of f in the direction of the vector v equals 2i minus 3j plus 6k. So let's start with that. Now the first thing we need to do is find the unit vector. We don't have the angle, so we can't use cosine and sine. But the unit vector is going to be the vector itself divided by the magnitude of that vector. So v is just 2i minus 3j plus 6k. To get the magnitude, it's going to be the square root of 2 squared plus negative 3 squared plus 6 squared. Now, 2 squared is 4, negative 3 squared is 9, 6 squared is 36. 4 plus 36 is 40, plus 9, that's 49. So we have the square root of 49, which is 7. So we can write the unit vector like this. It's going to be 2 over 7 times I minus 3 over 7 times j plus 6 over 7 times k. So that's it for the unit vector. So now we could find the directional derivative at this point. But first, let's find the partial derivatives of f with respect to the three variables, x, y, and z. So let's find f of f sub x. So we're going to treat y and z as if they're constants. The derivative of x is 1. And so we're going to get this. It's going to be 3y to the third power minus 2z squared. So that's the first partial derivative. Now let's find the other ones. So let's start with f sub y. So we're going to treat x and z as if they're constants. So it's going to be 3x times the derivative of y to the third, which is 3y squared. And this doesn't have a y variable, so that's going to be 0. So this becomes 9xy squared. Now let's find the other partial derivative. So this doesn't have a z value, that's going to be 0. And so it's going to be negative 2x times the derivative of z squared, which is 2z. And so this becomes negative 4xz. So now we can plug in everything into the formula. So the directional derivative of the function f with the three variables, it's going to be the partial derivative of f with respect to x times a. Now keep in mind, this is equal to f sub x with these three variables. But I chose to write just fx because it's a lot less to write, and I'm going to run out of space if I try to write all of this. So just keep that in mind. Then it's going to be plus the partial derivative of f with respect to y times b plus the partial derivative of f with respect to z times c. And a, b, and c come from the unit vector. So now let's plug everything in. So f sub x is 3y to the third minus 2z squared, and that's going to be multiplied by a. So this is a, this is b, and that's c. So that's going to be times 2 over 7. And then plus f sub y, which is 9xy squared, times b, that's negative 3 over 7. And then it's going to be plus f sub z, which is negative 4xz, times c, which is 6 over 7. Now, just to reduce the number of fractions, I'm going to factor out 1 over 7, since every term has a 7 in the denominator. So it's going to be 1 over 7, and then it's 3y cubed times 2, so that's going to be 6y cubed, and then 2 times negative 2z squared, that's negative 4z squared. And then it's going to be minus. So negative 3 times 9, that's negative 27. So we're going to have negative 27 xy squared. And then 6 times negative 4. So that's going to be negative 24 xz. So this right here is the directional derivative of a function with 3 variables. So now we need to evaluate the directional derivative at the point 3, 1, negative 2. So let's replace y with 1, and then let's replace z with negative 2. X is 3, y is 1, and then this is going to be 24 times 3 times z, which is negative 2. So that's going to be 6. Negative 2 squared is positive 4. Positive 4 times negative 4, that's negative 16. And then we have 3 times 27, which is 81. 24 times 3 is 72. 72 times 2 is 144. The two negative signs will make this positive. And so we have 6 minus 16, which is negative 10. Negative 10 minus 81, that's going to be negative 91 plus 144. So 144 minus 91. 140 minus 90 is 50. 4 minus 1 is 3, so that's going to be 53. So the answer is 53 over 7. So that is the value of the directional derivative at the point 3, 1, negative 2 in the direction of this vector. So now you know how to find and evaluate the directional derivative in terms of 2 variables, or if you're given a function with 3 variables. Now let's move on to our next problem. Given the function f of x comma y in the direction given by the angle theta, which is pi over 6, evaluate the gradient vector at the point 1 comma negative 3. Well, first we need to find the gradient vector. And it looks like this, like an upside delta symbol. So the gradient vector of f is equal to the partial derivative of the function with respect to x and the partial derivative of the function with respect to y. But those values are the x and y components of the vector. So that's what we need to do in order to find the gradient vector. We need to find the partial derivative of f with respect to x and y. So let's go ahead and do that. So here we have the original function. Let's find the partial derivative with respect to x first. The derivative of x in xy squared is 1. And the derivative of x cubed is 3x squared. So this is y squared plus 6x squared. Now let's find the partial derivative with respect to y. So it's going to be x times 2y, and the derivative of 2x cubed with respect to y is 0. So this is just 2xy. So now we can write the gradient vector. So we can write it this way: f sub x, which is y squared plus 6x squared, and then f sub y, which is just 2xy. And then we can write that in component form. So this will be y squared plus 6x squared times I plus 2xy times j. So this is the gradient vector in terms of x and y. Now, let's evaluate the gradient vector at the point 1, -3. So y is -3 and x is 1. And then it's 2xy, or 2 times 1 times -3. So -3 squared is 9, plus 6, that's 15. So this is going to give us 15 times I, and then 2 times -3, that's -6. So the answer for part A is 15I minus 6j. Now let's move on to part B. Find and evaluate the directional derivative at the same point. So how can we do that? Well, we need to know that the directional derivative of the function is the dot product of the gradient vector and the unit vector. So first we need to find the unit vector. The unit vector is going to be cosine pi over 6, comma, sine pi over 6. So the unit vector is going to be cosine pi over 6 is the square root of 3 over 2. Sine pi over 6 is 1/2. So now we could find the dot product between those two things. So this is going to equal the gradient vector, which I'm going to write in this form, times the unit vector. And let's not forget the dot product symbol. So what we're going to do is we're going to multiply this part with the square root of 3 over 2. So it's just going to be y squared plus 6x squared times the square root of 3 over 2. And then plus. So now we need to multiply those two parts. 2 times 1/2 is 1, so we're just going to get plus xy. So that right there is the directional derivative in terms of x and y. So now we need to evaluate the directional derivative at the point 1, -3. So this is going to be -3 squared plus 6 times 1 squared times the square root of 3 over 2, and then plus xy, 1 times -3. So this is 9 plus 6 times root 3 over 2 minus 3. So we have 15 root 3 over 2. -3, we can write that as 6 over 2. That's still equal to 3. But now we can combine the fractions into a single fraction. And so now we have our answer. So it's 15 root 3 minus 6 over 2. So that is the value of the directional derivative at the point 1, -3. So that's it for this problem. Number 4. Given the function f, find the gradient of f at the point 2, 3, 1. So to find the gradient vector of a 3-variable function, it's going to look like this. So we can write it this way: f of x, comma, f of y, comma, f sub z. Or we could write it in component form. So we got the partial derivative of f with respect to x times I, and then the partial derivative of f with respect to y times j, plus the partial derivative of f with respect to z times k. So let's start with our function, which in this problem it's 2x z to the third minus 3y z squared. So let's find the partial derivative with respect to x first. So the derivative of x is 1. So we're just going to get 2z to the third power. There's no x variable here, so that's a constant. That will be 0. So now let's find the partial derivative with respect to y. There's no y variable in that term, so that's 0. So it's going to be negative 3 times 1 times z squared, or simply minus 3z squared. Now, let's find the partial derivative of f with respect to z. So it's going to be 2x times the derivative of z to the third, which is 3z squared, minus 3y times the derivative of z squared, which is 2z. And so that's going to be 6x z squared minus 6yz. So now we have our 3 partial derivatives. Now, let's move on to write in the directional derivative. So I'm going to go straight to this form. So it's going to be the partial derivative with respect to x, that's 2z to the third times I. Let's put this in parentheses. And then minus 3z squared times j, and then plus the partial derivative with respect to z. That's going to be 6x z squared minus 6yz times k. So that is the gradient vector in component form in terms of x, y, and z. So now the next thing we need to do is evaluate the gradient vector at this point. So x is 2, y is 3, z is 1. So let's go ahead and plug that in. So this is going to be 2 times 1 to the third, and then minus 3 times 1 squared, and then plus 6 times 2 times 1 squared, minus 6 times 3 times 1 times k. So that's going to be 2i minus 3j. 6 times 2 is 12, minus 6 times 3, which is negative 18. 12 minus 18 is negative 6. So we get minus 6k. So this is the value of the gradient vector at this point. So that's it for part A. Now let's move on to part B. Find the directional derivative of f at the same point in the direction of the vector v. So to find the directional derivative of a 3-variable function, it's simply going to be the dot product of the gradient vector and the unit vector. So let's find the unit vector first. So we know that's going to be v over the magnitude of v. So v is 4i minus 1j plus 8k. And the magnitude is going to be the square root of 4 squared plus negative 1 squared plus 8 squared. So 4 squared is 16. This is 1, and 8 squared is 64. 16 plus 64 is 80, plus 1, that's 81. So the square root of 81 is 9. So we have 4i minus 1j plus 8k over 9. So we can write the unit vector in this form. It's going to be 4 over 9i minus 1 over 9j plus 8 over 9k. So now let's plug in the point. So the directional derivative at the point 2, 3, 1 is going to be the gradient vector at that point, 2, 3, 1, and the dot product of the gradient vector at that point and the unit vector. That's what I meant to say. So we have the gradient vector. It's 2, negative 3, negative 6, based on what we see here. And the unit vector is 4 over 9, negative 1 over 9, and 8 over 9. So to calculate the dot product, we need to multiply these two first. So it's going to be 2 times 4 over 9, and then plus. Next, we need to multiply the y values together. So that's going to be negative 3 times negative 1 over 9, and then plus the z values together. So negative 6 times 8 over 9. So this is going to be 8 over 9 plus 3 over 9 minus 48 over 9. 8 minus 48 is negative 40. So we have 3 over 9 minus 40 over 9, which gives us negative 37 over 9. So this right here is the answer. So that is the value of the directional derivative at the point 2, 3, 1 when f is in the same direction as, when the directional derivative is in the same direction as this vector v. Now another way that we could have gotten the same answer is we could have found the general form of the directional derivative first using this formula. It would be the partial derivative with respect to x times a plus the partial derivative with respect to y times b plus the partial derivative with respect to z times c. And keep in mind, we have a, b, and c. So looking at my notes, f of x was 2z to the third power, and then this would be times 4 over 9, and then f of y, that was negative 3z squared, that would be multiplied by negative 1 over 9, and then f of z is 6x z squared minus 6yz, and that will be times 8 over 9. So thus, we can write the directional derivative of f is equal to, so this is going to be 8 over 9 z to the third power, and then plus 1 over 3 z squared, plus 6 times 8 is 48 over 9. That can be reduced to 16 over 3. So that will be 16 over 3 x z squared minus 16 over 3 yz. So that is the general formula of the directional derivative if you needed to find it. And then at this point you can plug in x, y, and z. So 2, 3, 1. And once you plug that in, you should get the same answer of negative 37 over 9. So that's another way in which you could have evaluated the directional derivative of f at this point. So that's it for this video. Now you know how to find the directional derivative, and you also know how to find the gradient vector for a 2-variable function or a 3-variable function. Thanks again for watching.